If every multi-step flow is a one-off script, you will drown in glue code. We will build a simple workflow runner that chains steps, stores checkpoints, and makes complex flows manageable. You have scripts that call an LLM, then another script that massages outputs, then a third that fails when a value is missing. That fragmentation costs time and creates bugs. By the end of this video, you'll understand a small Python pattern that keeps state, makes steps reusable, and helps you resume or debug quickly. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced with simple, concepts-first Python that helps you solve bigger, real-world problems. Now let's ground this in something real. Teams use multi-step LLM flows for incident triage, report generation, and data enrichment. The pain point is orchestration, passing intermediate answers, applying deterministic tools, and keeping safety checks. Success looks like a flow you can pause, inspect, and rerun from any checkpoint. At its core, a chain is a list of steps and a shared state object. Checkpoints are named entries in that state you can read or overwrite. This gives you reproducibility, cheaper tool calls, and a clear audit trail. The pattern is small, but it scales. Fewer surprises when you add monitoring, caching, or parallel steps. We will build a tiny incident processing pipeline. It will make a human summary, extract a numeric factor with a deterministic tool, generate candidate responses, redact risky words, and then show how checkpoints let you resume or test individual stages without rerunning everything. Now we'll show the first minimal chain. This snippet creates a tiny two-step chain with a checkpointed summary. We define the variable task as our toy incident text and an empty check dictionary to hold intermediate results. The function LLM acts as a deterministic mock LLM that trims the input after the colon and returns a concise summary string. We call LLM with task, store the result under check R sum, and keep it available for later steps as a clear checkpoint. This mirrors a minimal LLM call followed by state capture for reuse. The printed summary confirms the chain runs, and a checkpoint is saved for downstream steps. Next, we'll add a cheap tool that extracts a number from text. This snippet extracts a numeric fact with a simple tool and checkpoints it. We import re and define tool stats, a tiny function that finds numbers in the text and returns the first one as a factor. The function is deterministic and fast, turning unstructured text into structured data that we can feed into later logic. We store the parsed fact in check facts, giving us a concrete, testable checkpoint alongside the earlier summary. Tools like this reduce LLM calls by doing deterministic work cheaply. The printed factor shows the tool recovered a reusable metric from the incident text. Next, we'll generate a few stylistic candidates and pick one. This snippet generates labeled candidates and selects the best with a scoring rule. We create styles and body, then define score to prefer strings mentioning CPU while penalizing length. We call LLM for each style and replace the summary label so candidates differ by style. We store all candidates in check cans, and pick the top choice via sorted with our score function, saving it as check top. Increasing the length penalty favors shorter outputs and can change the winner. Lowering it allows more verbose choices. The printed top value shows the selected candidate that best meets the current, and you can tweak the scoring function to reflect your own priorities. For example, preferring clarity over brevity, or penalizing uncertain language. Next, we'll apply a safety pass to redact risky terms. This snippet applies a simply guardrail to redact risky tokens and saves the result. We define banned as a set of disallowed terms and sanitize a deterministic function that replaces any match with redacted. It processes the previously selected candidate in check top and writes the safe version to check safe. This creates a clean checkpoint for downstream use. improving reliability and safety without another LLM call. If you add more terms to band, more content will be redacted. Removing terms will preserve more detail. The printed guarded value confirms the safety pass took effect on T and gives you a deterministic audit trail for what was removed. Next, we'll wire these steps into a tiny executor that records checkpoints. This snippet runs a 3-step workflow that records checkpoints for resume and debug. We define steps as lambdas. Select the best candidate, apply sanitize, and compute the numeric factor with tool stats. A compact executor iterates through steps and writes outputs to check with S0, S1, and S2 keys, forming explicit checkpoints. This makes each stage inspectable for monitoring, latency timing, or incident-style diffs. You can reorder or extend steps to add validation or caching. Fewer steps reduce latency, but may skip useful checks. The printed pipeline result shows the safe text slice and the recap in 3 crisp points. It is a small chain pattern that stores intermediate state as checkpoints. Use it when flows have several distinct operations, when you need resume or debugging, or when deterministic tools can reduce LLM load. One caveat: too many checkpoints can clutter state and slow iteration, so pick meaningful save points. Next step: scale this exact approach by timing each step and adding an ANN index or a cache for the LLM results. That way you can handle a bigger corpus and replay only the slow pieces during debugging. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.